Alright, everyone. So let's solve this question from May 2022. You will investigate triangles, interact with this stage control to see how the equilateral triangles are formed. So at this stage, there is one triangle, and at stage 2, there are 5 triangles, right? Stage 3, 9 triangles, and stage 4, 13 triangles, right? So it says, question 8.A says, describe how stage 2 includes 5 triangles. So we can say, for the description of it, we can say that there are 4 internal congruent triangles and one large outer triangle. Hence, totally 5 triangles. That's how we can write down our answer. Part B says the table below shows number of triangles in each stage. Write down the missing values in the table up to row 6. So we can notice that there is a pattern being followed. Plus 4, plus 4, plus 4. So here the next value becomes 17 and the next value becomes 21. Describe in words 2 patterns in the table for the number of triangles. First things first. As the stage number increases, by 1, we can see that number of triangles um, increase by 4. That's the first pattern. Another pattern is that all numbers are odd, or you can say not divisible by 2. Alright, that could be another thing. So that would be a description in words. Write down a general rule for t in terms of n. So that's very easy. We have 1, 5, 9, 13. A difference of 4 is present in all cases. So we have a plus n minus 1 multiplied by the common difference. The value of a is going to be 1, and the common difference is going to be 4. So we are left with 1 plus 4n minus 4, and we get a result of 4n minus 3. Alright, Then we are told write down a general. Okay, then we are done with that. Verify your general rule for T. So that's very easy. How can we verify this part? In order to verify it, we have to make sure that our answers match as compared to what is present inside the table. So let's say the value of n is 2. So we get 4 into 2 minus 3. That becomes 8 minus 3, which becomes 5. Let's say the value of n is 4. So we get 4 into 4 minus 3, which becomes 4 times 4 is 16, and 16 minus 3 becomes 13. N equals 6. We get 4 times 6 minus 3, which becomes 24 minus 3, which becomes 21. So that's how we can verify our general rule. Write this down so that we can move forward. Okay, wait a second. Yeah. So the next part says interact with the stage control to see how the perimeter of the outer triangle increases. So show that the perimeter of the outer triangle in stage 4 is going to be 24. So we know that at the stage 4, the outer triangle has a side length of L equals to 8 units, right? And since the triangle has supposedly 3, um, for example, here it was, yeah, it has 3 sides, so automatically we must know that 8 multiplied by 3 gives us the answer of 24, as simple as that, right? I hope that makes sense as well. First, let's complete the and predict the values and record these in the table. Let's complete the table first. Okay, so we can see that the side length of the outer triangle here there is increasing by 1, here it's increasing by 2, here it's increasing by 4. In fact, no. Basically, it's multiplying by, okay, there is a multiplication. So it's not a quadratic sequence, neither is it a linear sequence. So here we are going to have 16 and here we are going to have 32. Alright. As far as the perimeter is concerned, since each and every triangle we know that it has 3 sides in total, so 16 times 3 is 48 and 32 times 3 is 96. Describe in words a pattern in the table for the side length L. So a pattern for L includes um, the idea that the side length essentially doubles with each n value. All right, that's a pattern. How many patterns do we need for L? One or two patterns? Let me check. A pattern in the, yeah, okay, one pattern for L. And let's write down one pattern for P. With the perimeter, we can say that the perimeter doubles with each stage or each consecutive stage. That's going to be fine. All right, write this down. Now, then we are being told, write down your general rule for P in terms of n. Let me just erase this. So in order to write a general rule, we must know that it's a geometric progression. So it has an initial geometric progression is always written as 2 raised to the power of n minus 1. And since it has an original, why am I writing 2 raised to the power of n minus 1? Because the common ratio is basically the previous term, sorry, the next term divided by the previous term. So the next term is 6 and the previous term is 3. And I explained this. I have recordings in my bundle for this. You can um, ask me for the bundle here. That's going to be fine. So 6 over 3, that gives me an answer of 2. And since the principal term is 3, so we get 3 multiplied by 2 raised to the power of n minus 1. That's going to be the right answer. Test and verify. So let's test the values. For n equals to 2, if we were to write 3 multiplied by 2 raised to the power of 2 minus 1, we will get an answer of 6. And here we go. Let's say n equals to 6, so we get 3 multiplied by 2 raised to the power of 6 minus 1, which is essentially 5. So 2 raised to the power of 5 is 32, and 32 times 3 gives us an answer of 96. So here we go. Our answer is justified as well. Verified as well, not justified. We'll do the justification part right now. Alright, then we have the justification. Now look, at the first stage, the side length was of 1, right? And at each subsequent stage, what happened? The outer side length doubled relative to the stage n. So, what's happening here? Have a look. The outer side length is doubling. Okay? So this results in a general geometric equation, which is n minus 1. A power of n minus 1 over a base. Now, because an outer shape is always an equilateral triangle, the perimeter should consist of three equal sides of length L. So substituting the formula of the perimeter, that gives us 3 multiplied by 2 raised to the power of n minus 1. So if anyone wants me to write it in a word form, I can write this down. Look, first things first, at stage 1, side length is 1. As each stage passes, the outer side length doubles. Relative to stage of n minus 1. Now we know that the common ratio is of 2 and a triangle has 3 sides. So when we apply the entire notion that we have studied, we get a result of 3 multiplied by 2 raised to the power of n minus 1.